Hello and welcome to This Explainer. I'm absolutely thrilled to have you here. Today, we're mastering a skill that perfectly bridges the gap between mechanical engineering and everyday survival. Yep, we're talking about changing a car tire. But we aren't just looking at this in a vacuum. No, we're going to examine the exact, precise mechanics of this process across 4 completely different, highly realistic scenarios. So let's dive right in. Picture it. You're driving along, enjoying the ride, and suddenly you hear it. That dreadful, rhythmic thud, thud, thud coming right from your wheel well. The steering wheel starts to shudder, your heart rate spikes. It's a flat tire. Now, for a lot of us, this induces absolute panic. But honestly, it really doesn't have to. What we're going to establish today is that panic is entirely unnecessary once you understand the core mechanics of what needs to happen next. Once you have a precise mental checklist, that terrifying thud just becomes a simple signal to activate a routine. Here is our roadmap for today. Number 1, safe and flat ground basics. 2, highways and busy roads. 3, nighttime and bad weather. And 4, cars with no spare. Kicking things off with Section 1, safe and flat ground basics. The absolute gold standard of tire changing. Okay, before you even think about touching a tool, you absolutely must safely freeze the car's momentum. First things first, pull over to a safe, flat area that's completely away from traffic. Immediately switch on those hazard lights so everyone else on the road can see you. Then, you literally lock the vehicle in place. Apply the handbrake firmly. If you're driving an automatic, shove it into park. If it's a manual, put it into first gear or reverse. Look, this part is non-negotiable. You literally cannot safely jack up a machine weighing thousands of pounds if there's even a tiny chance it might roll away from you. Now, let's talk about the jacking point. You see, you can't just shove a jack anywhere under the chassis and start pumping. A jacking point is a specifically engineered, heavily reinforced area under the car. It's usually marked right near the wheel arch. It's designed to safely bear the intense, concentrated weight of the vehicle being lifted. If you lift the car anywhere else, well, it's incredibly dangerous. You could actually cause the jack to punch right through the floorboards, or the car could just slip off and crash down. Yikes. All right, here is where the physical exertion comes in. Imagine a little cartoon mechanic getting to work here. It's all about physics. First, get your spare tire, jack, wheel spanner, and locking wheel nut key out of the trunk. Now, here's a vital physics lesson. You have to loosen the wheel nut slightly before lifting the car. Why? Because you need the friction of the tire pressing against the ground to push back against your spanner. If you lift it first, the wheel is just going to spin uselessly in the air. Once they're loosened, raise the car at that jacking point until the flat is completely off the ground. Take the nuts off, physically pull off the bad tire, pop on the new spare, and hand tighten the nuts. Then lower the car just a tiny bit until the new tire barely touches the ground. Now tighten the nuts firmly in a crisscross pattern. Think of it like drawing a star. This ensures the wheel is seated perfectly flat and absolutely secure. Finally, lower the car all the way down and give those nuts one last really tight pull. Moving right along to Section 2, highways and busy roads. Elevating the tension, prioritizing safety. So we're taking the exact mechanics we just learned and introducing a severe complication, high-speed traffic. Listen carefully because your physical safety from moving vehicles is the ultimate priority here. Do not stop in the middle of the road. Instead, slow down gently, no sudden braking please, and steer to the safest possible place. That could be a lay-by, a petrol station, or a wide, hard shoulder. Hazards on, immediately. Now, get all your passengers out of the car and far away from traffic, preferably behind a safety barrier. If you've got a reflective jacket, put it on right now. And if you have a warning triangle, place it out, but only, and I mean only, if it's entirely safe to do so. You must be completely clear of traffic before you even think about fetching that jack. Which brings us to a really critical question of situational awareness. Say you're on the hard shoulder of a busy highway. The flat tire is on the left side, the exact side facing rushing traffic. Should you attempt to change it? The answer is a definitive, absolute no. No way. Do not attempt it. Call roadside assistance instead. Honestly, it doesn't matter how fast or efficient you think you are. You should never, ever risk physical harm from moving traffic for a piece of rubber. The mechanical steps might remain exactly the same, but the environmental risk is just way too high. Let the professionals handle it with their heavy-duty safety vehicles. Next up, Section 3, nighttime and bad weather. Conquering the elements. Imagine the scene. It's pitch black out, it's pouring rain, the ground beneath your car is quickly turning into slick, unstable mud, and you are totally stranded. You know what? It's completely valid to feel anxious here. It's a spooky, really tense situation. But remember, we don't panic, we just apply our precise, logical solutions. Let's see how this builds on our core mechanics. First up, visibility. Stop in the brightest, safest place you can find. Keep your phone charged, use its flashlight, and make sure you're visible. But again, never stand in traffic to do so. Next, the ground. Wet, muddy, or soft ground is super dangerous because the jack can easily slip. The incredibly practical solution here is to just place a flat wooden board or something similarly firm directly under the jack. This acts like a snowshoe, distributing the weight evenly over the soft mud. Finally, your physical handling. Work slowly. Your tools and those metal wheel nuts are going to be wet and super slippery. And this is crucial. Keep all your wheel nuts together in one secure spot. Because dropping a small, dark metal nut into wet mud at midnight, yeah, that is a total recipe for disaster. Once the spare is fitted, drive slowly until the weather conditions actually improve. Now for Section 4, Cars with No Spare, the modern twist. Actually, before we talk about having literally no spare, we need to understand what most cars have today instead. It's called a space saver. This is a temporary, highly restricted spare tire. It's much thinner and smaller than your normal tire. And guys, it is absolutely not meant for long distance or high-speed driving. Its single mechanical purpose is to limp your vehicle safely to the nearest garage so you can repair or replace the original damaged tire as soon as humanly possible. But a lot of modern cars have entirely eliminated the spare tire altogether just to save weight. So instead, you might pop the trunk and find one of two modern technologies. First, a tire sealant kit. This is just for small punctures. You basically connect a bottle of liquid sealant and an air compressor directly to the tire valve, inflate it, and the sealant theoretically plugs the hole from the inside. That lets you drive slowly to a garage. Alternatively, you might have run flat tires. These are specially engineered tires with heavily reinforced sidewalls. They literally support the weight of the car even when all the air pressure is completely gone, which allows you to continue driving for a limited distance. Pretty cool, right? However, it is absolutely vital to know the limitations of your equipment. If you have a tire sealant kit, you have to look at the structural integrity of the damaged tire. If the tire is badly torn, if the sidewall is physically damaged, or if the tire has actually come completely off the metal rim, well, a sealant kit is completely useless. You simply cannot inflate a tire with a massive gash in it. In these precise scenarios, your only logical option left is to call roadside assistance. And what if you're relying on run flat tires? Well, you absolutely must remember this magic number, 50. That represents 50 miles per hour, or roughly 80 kilometers per hour. That is generally the strict maximum speed limit you can safely drive on a punctured run flat. And typically you can only do so for about 50 miles total. Always check your specific car manual, but remember that exceeding these limits severely compromises the mechanical safety of that reinforced sidewall, and you're risking a total catastrophic blowout. So, we've covered the gold standard basics, the high-stress highways, the muddy midnights, and the nuances of modern spareless vehicles. I'm going to leave you with this final empowering question. When, and I mean when, not if, you hear that sudden pop on the road, will you be a victim of circumstance, or are you fully prepared to safely take control? Go open your trunk today and identify exactly what setup you actually have, because knowledge is absolutely the ultimate tool in your trunk. Thank you so much for joining me for this explainer.